object is moving, momentum keeps it moving. When an object is spinning, momentum will keep it spinning. Since motion in a rotating system is angular, the momentum a spinning object develops is called angular momentum. Angular momentum is similar to linear momentum. It depends on how fast the object moves and how massive it is. There's just one little catch: the shape of a rotating object. Can you figure out why the spin of this figure skater changes, even though there's no outside torque being added? Bringing the arms in close to the body reduced her moment of inertia. The angular momentum did not change, but when the moment of inertia decreased, the speed increased. That way, the momentum was conserved. These are the two factors that determine angular momentum: the speed of rotation, omega, and the moment of inertia. This fact that changing moment of inertia changes the angular speed is particularly important in the satellite industry, where angular momentum is vital to the orientation of the satellite. Sometimes extensions like solar panels are deployed after launch, changing the moment of inertia. If the moment of inertia goes up, the speed of rotation goes down to conserve the momentum. As in linear systems, momentum in rotating systems is most important for the impulse it can produce when the momentum changes. The only difference is that the impulse is a torque acting over a period of time. The impulse can become momentum. The momentum can be turned back into an impulse. In this case, the angular momentum of the flywheel is changed into an impulse with a powerful torque acting over a short time. A linkage translates the torque into a linear force at the punch. It's this relationship between impulse and angular momentum that enables technicians to predict and control rotating mechanical systems. Whether you're using torque to rotate a mass and create angular momentum, or turn angular momentum into an angular impulse that involves torque, what you end up with is always the same as what you started out with, as long as the system is isolated. Angular momentum plays an important role in engines. In fact, an internal combustion engine cannot run without it. The pistons are only driven on the power stroke. It's a flywheel that uses that as an impulse to spin and gain angular momentum. That momentum is then used to drive the pistons through the other strokes. Many rotating systems are driven by the momentum of fluids, like this lawn sprinkler. The water has momentum because of its mass and speed down the hose. But when it gets to the nozzle, it encounters a bend in the pipe. In a sense, the water collides with that bend. In the collision, some of the momentum of the water becomes an impulse. That causes the arm to spin. This principle of using the momentum of a fluid to spin a mechanical rotating system is also used by turbines, like a turbocharger on an engine. Exhaust gases are accelerated to very high speeds to gain momentum. That momentum becomes an impulse acting on the blades of the turbine. This causes them to spin. The turbine then develops its own angular momentum, which is used to create an impulse and drive the fresh incoming gases into the engine under pressure. Momentum becomes an impulse, the impulse becomes angular momentum and is turned back into an impulse again. Here's a problem that engineers have not solved that involves angular momentum. The tires on an aircraft take a terrible beating during landing because they're not turning just before touchdown. As a result, they burn rubber on the runway. One proposal was to power the wheels in the air so they're spinning before touchdown. This would reduce their wear, but the idea has not been accepted. Can you figure out why? We'll give you the solution in the summary program.